So today we are going to start about the single phase AC circuit analysis. In the last lectures we have completed this DC circuit analysis up to transient behavior. Now we'll start with the single phase AC circuit. Okay. So the very first topic, like the basic knowledge I'm telling you for this one, like you know what is the difference between the DC and the AC supply. DC supply is like this, right? And AC supply is like a sinusoidal supply. Next thing, AC supply is the supply which we are used at our home appliances. Okay. DC we are using mainly in the form of battery. When you have studied the DC circuit, you use the battery symbol or cell symbol like this. But whenever you are using the AC symbol, like you are supplying AC, so the symbol of AC is like this. This shows a sinusoidal supply. Okay. So for that, DC frequency is how much? That is, DC frequency is 0 because it is not changing its output. But AC frequency is fixed. In India we used 50 hertz and mainly in outside India we use 60 hertz. Okay. So now here it comes under the effect of frequency only. Now, as you know, we'll have three types of load. One is the resistive load, another one is the inductive load, and another one is the capacitive load, right? So resistive is denoted by resistor R, inductor is denoted by L, and capacitor is denoted by C. As you know, resistance unit is ohm, inductance unit is Henry, and capacitance unit is farad. Okay. Generally they'll give you in millihenry, so you need to convert always in the standard unit, that is 1 into 10 raised power minus 3 Henry. Similarly, farad generally given in microfarad, so you need to understood it, 1 into 10 raised power minus 6 farad. Okay. So in this, suppose if you'll have one plain wire and one wire with a resistance, in which case can you tell me current can flow easily? If you are having one plain wire and one wire with a resistance, in which case current can flow easily? The plain wire or the plain wire, right? Similarly, if there is a plain wire or there is an inductor in a wire, in which case current can flow easily? Plain wire, because it opposes the flow of change in flow of current. Basically, what is the function of inductor? It opposes the change, right? Remember I told you that in case of inductor there is a plain wire. If from the very long time current is flowing, then it will behave as a plain wire. Okay. Yeah. Now suppose if we'll have again a plain wire and the wire with a capacitance, in which case current can flow easily, the plain wire or the capacitance one? Plain wire, right? So particularly in this case, what happen if current is flowing? Okay, it means there is some amount of resistance present in the inductor, yes or no? Like we'll have a plain wire, okay, and you'll have a wire with the inductor. Current can flow in a plain wire, right? So it means there is some amount of resistance present in the inductor, right? Then that resistance is known as inductive reactance. Okay, and inductive reactance is the resistance offered by inductor. Okay, understood? Basically, inductor is having some amount of resistance, and that resistance is technically known as inductive reactance, and inductive reactance is denoted by XL. And what is the formula for XL? That is omega L. Okay, what is omega? Omega is the angular frequency, and omega is equal to 2 pi f L. Okay, got it? According to you, what should be the unit of XL? As it's the form of resistance, right? So its unit is ohm. Clear? Hmm? Similarly, if we'll have capacitor resistance, then that resistance is known as capacitive reactance. Okay, and capacitive reactance is denoted by Xc. And what is the formula for Xc? That is 1 over omega c, that is 1 by 2 pi Fc. Again, its unit is ohm. Got it? Note down these formulas. These formulas are not given in your handbook also. Okay, note it down. Now suppose we'll have only resistor, then its resistance is resistance only. If we'll have inductor, then its resistance is XL. If we'll have capacitance, then its resistance is XC. If we'll have the combination of R and L, or we'll have the combination of R and C, or we'll have the combination of RLC, then in that case their impedance or their resistance is known as impedance, and impedance is denoted by Z always, as you have studied in 12th class also. So what is the formula for the Z? If there is a case of RLC, all the things are there, then the formula is R root of R square plus XL minus XC ka whole square. Okay, and or we can write it down in the rectangular form. Z is equal to R plus J of XL minus XC. Okay, similarly, if we'll have the load of R and C, then in that case Z is equal to root of R square plus XC square, because there is no L, right? And if there is no L, then there would be no XL, correct? So in this case Z is equal to R plus J, sorry, for if there is a capacitor, then in that case the formula is R minus J XC. Got it? Next, can you tell me the formula for the RL, right? So these are the all the formulas of resistance only. So everyone is unit is ohms only. Got it? You need to remember these formulas. Now next thing, actually in the single phase there are lots and lots of formulas. Okay. So in this there is three kind of question will come. I'll tell you. One question, like according to midterm, I'm telling you, one question will come of waveform kind of like this. They'll give you the waveform. Okay. Another second question they'll give you from the series RLC circuit. Okay. Another third question they'll give you from the parallel RLC circuit. Okay. Another fourth question they'll give you the question of capacitor as power factor improvement. Like I told you, four question, and in from these four question in your NTM, definitely three question will every time will come. Okay. And if I'll tell you according to syllabus, see what is the parallel circuit based question, and yeah, one another kind of question they'll give you from the resonance. Another will be the resonance. Another will be the RLC circuit, and another will be from the power factor or improvement of power factor. Okay, so one by one we'll do it. For that you have to learn so many formulas, but I am telling you just single thing. If you learn this thing, you can learn all the formulas from this impedance triangle only. Means you don't need to cram, just need to cram only impedance triangle. Okay, in impedance triangle, in the base we'll take the resistor resistance, that is resistance. In the perpendicular we'll take XL, or in the perpendicular here we'll take XC, and in the hypotenuse always there is a combination R and XL, and as you know, R and XL or R and XC combination is impedance, that is denoted by Z, right? Clear? Now from here, can you get up to apply the value for sin phi, value for cos phi, and value for tan phi. Remember, you must have studied in school. See, if there is RL circuit only, then we'll take XL. Okay. If there is RC circuit only, then we'll take XC. If there is all the combination like RLC, then that depends. If XL is greater, then we'll take XL minus XC. And if XC is greater, then we'll take XC minus XL. Okay. So from here, we'll get the sin phi, cos phi, and tan phi. Another, you need to get the apply Pythagoras theorem. Pythagoras theorem, you know, h square is equal to p square plus b square, right? Hypotenuse ka square plus perpendicular ka square plus base ka square. Base one is resistance ka square, and this one would be xl minus xc ka whole square. Can we say that z is equal to r square plus xl minus xc ka whole square? See, if I told you, if there is a combination of RLC, then we'll take the combination of XL minus XC. Okay, clear? Now, after multiplying current with the impedance, we'll get a voltage, right? So now we'll make voltage triangle. In the voltage triangle, earlier there was an impedance triangle, R, XL, or XC. Here is Z. But if we'll multiply current I into XL, I into XC, and I into Z, it will form a voltage triangle. Okay. I into R is how much? VR. What is VR? VR is equal to IR. That is the voltage drop across resistor. Right? Here is the voltage drop across resistor. Similarly, VL is I into XL, right? Because inductor resistance is XL only, है ना? So what is VL? VL is the voltage drop across inductor. Similarly, VC, that would be I into XC. Capacitor is there, voltage drop across capacitor. So here it would be VR, here it would be L or VC, here it would be total voltage. What is V over here? V is the total voltage. So again, we can apply the Pythagoras theorem over here and the sin phi, cos phi, and tan phi, right? And we can apply the Pythagoras theorem also. V is equal to R ka square plus VL minus VC ka whole square. Now next, if you'll multiply voltage with the current, what you will get it? Tell me. Like you multiplied, first there is a resistance, you multiplied current, then it will become voltage, right? Similarly, if you'll multiplied voltage with the current, it will become power, right? So now we'll study about the power triangle. Okay. So basically, first of all, we should know what is power. Now, you'll have three different category of power. One of the power is active power, another power is reactive power, another power is apparent power. Okay, active power is denoted by P, reactive power is denoted by Q, apparent power is denoted by S. Active power is also known as real power, and active power is also known as true power. Okay, active power standard formula is VI cos phi, reactive power standard formula is VI sin phi, apparent power formula is VI. Apparent power unit, like it is standard unit is watt, reactive power standard unit is VAR. VAR stands for volt ampere reactive, and apparent power standard unit is VA. VA is volt ampere. Okay. Active power is used where is the resistive load, mainly reactive power will use where there is a inductive and capacitive load, and apparent power is RL, RC and RLC. Resistive load mainly we are using at our home appliances like bulb हो गया, fan हो गया, okay. And inductive and capacitive power will use mainly at industries, factories like induction motor, okay. And apparent power mainly will use at transformer. Got it? Active power is the real power. Suppose just imagine that you are having a cup of beer, okay. So beer is almost filled up to here, right? Beer is around filled up to here. So that is the active power. That is the active power which you are consuming. And above there is a froth, right? So that is froth is the reactive power which you can't consume, correct? And you have to pay for both active and reactive. So that is their combination is known as apparent power. Understood? Now back to power triangle. Like we'll have power triangle like suppose we'll have voltage triangle. First VR, VL or VC or V. So from here we can get the power triangle. The voltage for power for the resistive load is active power, and active power is denoted by P. Power for the inductive or capacitive load is reactive power, and reactive power is denoted by Q, and the total power is apparent power, and the apparent power is denoted by S. Okay, so here is phi, so here cos phi, sin phi and tan phi you need to calculate. Again you need to calculate Pythagoras theorem, apply Pythagoras theorem. That would be S square is equal to P square plus Q square. Okay, cos phi is equal to P by S. Similarly tell me sin phi and tan. Next, this is from your paper question only. First of all, you one more thing, that is power factor. Okay, power factor is what? Power factor equal to cos phi. Cos is cosine of phi. Phi is what? Phi is the angle, voltage and current. Okay, like we have studied three triangles. So whenever they said power factor means cos phi. So cos phi is how much? R by Z. Okay. Whenever they ask you cos phi, again cos phi is VR by over here. Cos phi is VR by V. And if you'll have the power triangle values, then you'll use cos phi for this formula by S. Okay. So that depends. If voltage is given, then you'll use voltage triangle. If impedance is given, you will use impedance triangle. And if power is given, you can use power triangle. Got it? That is the power factor. And ideally that if there is a resistive load, then in that case phase angle is always 90 degree. So cos 90 is always 1. And ideally also power factor should be 3. Okay, power factor should be 3 means ideally cos phi should be equal to 1. But generally if we use inductive load or capacitive load means mainly in factory area, then in that case power factor reduces from 1, then it will reduce from 0.7 maybe 0.8. So it would be less than 1 in case of inductive and capacitive load. Okay, clear? Let's do this question, then we'll study about detail about the power factor. Yeah, you can write it down. Now this question, they said a coil of 0.8 power factor. First of all, you should know what is coil. AC circuit coil means there is a combination of resistance and okay. Coil means there is a combination of R and L. Next is the power factor. Power factor is cos phi, and cos phi is 0.8, is connected in series with a 100 microfarad capacitor. Means there is coil means R and L, and that is connected with a 100 microfarad capacitor across an AC supply. Remember I told you AC supply will need to make it like this. So RL value we don't know, but they give you the value of capacitor 100 microfarad. Write it down as it is. Then how much frequency? How much? That is 50 hertz. Okay. So whatever they have given, write it side by side. The magnitude of the potential drop across coil. Voltage across coil is the VRL. Yes or no? Because if coil is the combination of RL, then potential drop across coil is denoted by VRL, and the capacitor are equal. The voltage drop across coil and the voltage across capacitor is equal. Okay, both the voltages are equal. What they want to say, calculate the resistance and inductance of the coil, calculate the value of R, and we calculate the value of L. Got it? Understood? Now first of all, tell me how we can do it. See, in this case, VRL formula, VC formula, as I told you, I into XC, right? And VRL formula is I into ZRL. Remember, I told you whenever there is a combination of R and L, then they are resisted by Z, right? But I am not taking the complete Z because the complete Z would be the combination of R, L, and C. That's why their coil impedance I denoted by only ZRL, and complete impedance would be denoted by Z. That includes C also. Correct? Now in this case, whatever the value of current we don't know, but that would be cancelled out because current in coil and capacitor is same, and XC is how much? 1 by omega C, right? And ZRL formula is how much? A root of R square plus XL ka square. Correct? Understood? Now 1 by omega C, we can get the value of C also. X 1 by omega C, omega is 2 pi, F is how much? 50, and capacitor value they have already given, that is 100 microfarad. 100 into 10 raised to power minus 6. Got it? Clear? Now after solving, we'll get some value of XC, right? We can substitute it here, then we'll get one equation. Whatever value we are getting, we'll put it there and you will get a something value, right? XC after solving, I'm telling you the value that would come as 31.8 ohm. So I'm writing here 31.8 ohm. This is the one equation we are got it, that is R square plus XL square is equal to 31.8, right? Now next thing they have given the thing that VRL is equal to VC and cos phi is 0.8. They have given the power factor of the coil, right? So can we say that cos phi RL is equal to 0.8? Why I have wrote it RL? Because they have specifically mentioned that power factor is for the coil only. So cos phi formula, as you know, R by Z, right? So the coil impedance is how much? ZRL only, correct? R value we don't know, R as it is, and from here we can get ZRL. ZRL value we will get it here, that is 31.8. This is the ZRL value now, the coil impedance. So we can substitute here 31.8, correct? So from here, can we get the value for R? Tell me. Can get the value for R over here, and after solving we'll get R as 25.46. okay, if you got the value of R, you can substitute it here, then you will get the value of XL always. Just to try to solve it in your homework. XL value will get it as 19.1 ohm, and then you need to get L value. XL is equal to 2 pi FL, so L value you will get it as 60.81 millihenry. Okay, write down all these values. This is the current is across this. Let us R1. So VR1 is I into R, right? VR1 is 20, I is 55. Get the value for R. Similar, I is voltage is. Can we get direct ZRL? Not the individual value, but we'll get ZRL, right? Similarly, we can get the value XC, right? Because VC is equal to I into voltage across current, right? Now see for this one, total 140 volt one across the two resistors and the inductor. Can we say R ka square plus VL ka square, right? Voltage is 140. Now we can combine it. So what we can write down? I into R1 plus R2. R1 and this is R2 plus square, right? Plus I in XL ka square, right? So from here 140 R1 IU, and you can get combined it, you get I into R1 plus I into R2 plus I into XL, right? I you can take it common, then it will become R2 ka square plus XL ka square, then this will become ZRL. Yes or no? And ZRL value you already know. So from here you can get R2 and XL. If you know all these values and the total, then can you get the total impedance? And then you will get the, you already know the total current, then you will get the total. Okay, basically I'm saying if all these values, value for R1, value for R2, XL and XC, can you get the total impedance? Total impedance formula is Z is equal to root of R square plus XL minus XC ka whole square. XC you calculated, XL you calculated, R you calculated. Can you get total impedance? And after getting total impedance, you'll get the voltage as well by applying the formula V is equal to I into Z. I is given, Z you calculated, get it, right? See, in this question, first of all, we have to make the diagram. A current of 5 ampere flows through a non-inductive resistance. Non-inductive means only resistance. They just gave to confuse the student. With the coil means resistance is connected with the coil, and as I told you, coil is the combination of R and L always. When supplied at 250 volt means voltage is how much? 250 volt, and frequency is how much? 50 hertz. Then the voltage across R is VR is how much? 125 volt, and the voltage across coil means VRL is equal to 200 volt, right? So we need to calculate this R, this R. Let us consider this one would be R1, R2 and XL. Okay. So tell me, how can we do this? See, we know the formula, that is VR is equal to I into R. So I is 5, VR is 125, R would be 125 by 5. That would be 25, right? So we get this resistance, and similarly VRL is equal to I into ZRL. RL is 200 volt, I 5 ampere, ZRL is how much? That would be 40. For ZRL is how much? 40. Okay, ohm. And now we need to calculate the value of R2 and X2. And then we need to calculate power absorbed. Power absorbed formula is P is equal to I square R, right? If you know current, if you know the total resistance, then you will get the power absorbed also. And total power is apparent power, that is S is equal to VI. Total voltage is given, total current is given, then we'll get the total power, right? Now our question is how we can get the R2 and XL2 value. So ZRL we got it as how much? Root of R2 ka square plus XL ka square, right? ZRL we got it as 40, root of R square plus XL ka square, correct? Now if we'll be able to get cos phi, then we can do further. Cos phi is how much? According to the voltage triangle, tell me what is cos phi. So basically if we'll get cos phi by the formula, we can get sin phi. Sin phi is XL by Z. Z we can get it by as V equal to IZ formula, right? V we know, V is equal to I into Z. Z will get it, sin phi we get it, and from here we can get XL. And if we get the value of XL, then we can get the value of R as well. All the values are known now. Understood?